Our next problem is with inefficient compute resources. With the monolith, compute resources, mainly CPU and RAM, are divided across all components. We have a single process, the monolith, that consumes these resources and uses them for all its internal components, and this is not always the ideal case. For example, if a specific component needs more resources, there is no way to do that. We can't allocate more CPU or memory to a specific component that needs them. We will have to allocate more compute resources to the whole monolith, which will give them to all the components. And this is very inefficient. So what would we do to avoid this with microservices? Well, with microservices, the componentization via services attribute comes to our help. Since the various parts of the software or the components run as a service and not in process using libraries, we can allocate each one of them the correct compute power it needs. It's not possible to allocate resources to different code segments inside a process, but it's definitely possible to do that to the process itself. And with microservices, each service, as we have already discussed, run in a process of its own. So with our microservices system, we can do this. This is the system with the 5 services, each in its own process. And as you can see, we allocate different resources for each one of them. For example, a service that does not need a lot of resources is assigned 2 vcores and 4 GB of RAM, but another one, which probably does a lot of computations, is assigned 8 vcores and 16 GB of RAM. And as we said, this is possible because every service runs in its own process. And this is how microservices solve the inefficient compute resources problem.